Working with blocks of data. There are many times when you want to do the same operation on all the memory locations in a block of data. There are two ways that you can do this: using direct addressing, or in a more efficient way, using indirect addressing. If you use direct addressing, you have to address each memory location separately. If there happen to be a lot of addresses in the block, then you'll have to write a very long sequence of instructions to access each in turn. This takes both time and memory. If instead you choose to use indirect addressing, you can do the same thing to each memory location by looping through from the starting to the ending address. This makes your code much more compact. The instructions, which require the use of a pointer register and an offset, are a little more complicated to use, but the efficiency you gain using this method makes it worth the effort. Back in the repetition session, we looked at the repeat until loop. Remember that it's a post-test structure that has four main parts: the initialization of a test value, the actual looping instructions, modification of the test value, and the test itself. Using that as the basis for working with a block of data, the initialization is actually to the starting address. The instructions inside the repeat until loop perform the desired operation on that particular address, and then the address is modified. This new address is compared to the last address in the block. The looping operations are repeated until all the addresses have been accessed. So changing the testing variable from a value to an address is a pretty minor change. The one thing you'll have to remember, though, is to use a register big enough to hold an address. Luckily, each of the pointer registers is specifically designed to hold an address. Index registers are used for indirect addressing, or indexed addressing as it's sometimes called. All processors have at least one index register. It's this register that you'll initialize to the starting address of the block. Just as you would for any other initialization, you'll use immediate addressing to move the starting address into the index register. Recall that indirect addressing involves a memory location, a pointer register, and occasionally an all-purpose register. It's normally used to access individual elements within a block of data, such as an array. Using the pointer register to identify where you are in the block, it's easy to move through the block performing the same operation on each element. Typical applications include updating an element with an increment, a decrement, or a clear operation, retrieving an element with a load or move operation, or moving an element with a series of load, store, and move operations. So the address used in an indirect addressing operation is a calculated one. It assumes that the index register already contains a valid address. The instruction itself contains an offset that gets added to the address in the index register. This calculated address is the one that's used to access the data. Say, for example, the index register is initialized to the address 9000. If the offset is 2, then the calculated address will be 9002. This is the address the instruction will use. If the offset is 6, the calculated address would be 9006. It's important to remember that this calculated address is not stored anywhere. It's simply used to perform the operation. The index register is not changed, nor is the offset. Modifying the address is very simple. If you're moving up through a block of memory, you'll increment the register. If you're moving down, you'll decrement it. Look for instructions that work specifically with the processor's index register. When you make this change to the register, adding the same offset to the modified value will give you a new calculated address. This means the next time you go through that loop, you will access the next address in the block. The last operation in the repeat until loop is to compare the address stored in the index register to the last address in the block. Look for a compare or a test instruction designed specifically for the index register. If the address in the register is different from the ending address, you haven't reached the end of the block yet. Program flow must be designed to go back and repeat the loop again. It will continue looping until the index register has been changed to the point where it's equal to the last address. You've now reached the end of the block and will continue on with the rest of the code. So to recap, block operations are best executed using variation of a repeat until loop. The operations typically done with a block of addresses are things like updating, retrieving, or moving elements. To do this efficiently, you use indirect addressing. The operand includes both an index register, which holds an address, and an offset, that together form the actual address used in the operation.